Yes, or 15.
15, 16, 17, and 18. So they are just 4-year papers. So you are not required to do all the topicals. So that is why I believe this thing, that once you people would be done with that all stuff, it would be helpful for you. Okay. So here we go. Bismillah. Here we go. So when we talk about this topic, yani momentum, dynamics main part is momentum. In momentum, the main area of discussion is actually the main area of discussion is uh, that we have to talk about momentum, its definition. Then this topic is linked with different areas. It is not the independent topic. You know, this topic has some linkage. I mean, it's really true that momentum questions are very hard, but once they are connected with other topics like kinematics, like your kinetic energy and all that stuff, these topics get more detail and they become more hard. So that is why, if I will I mean, you people have seen while solving the kinematics question that most of the questions are independent, but in some of the questions momentum topics is included. So entirely 5 to 6 MCQs are there from your momentum, right? Sometimes they are mixed, but entirely momentum. And then they have a sort of theory question like 8 to 12, and then they have a blend with kinematics, work energy, power. Okay, so here is just a flow chart. I believe that it will be helpful for you. That flow chart tells us that we have to talk about change in momentum, Newton's second law, Newton's third law, then momentum ki different types, glancing momentum, elastic collisions, inelastic collisions, then law of conservation of kinetic energy, etc., etc. This all is to be discussed here in this topic. Uh, okay, is it clear to all?
Yes, sir.
Okay, सारे उनको ऊपर भेजो. Now, if we say that momentum is then impact of motion, yani this is just a detailed definition. The important thing, what is for your choice, that is the definition of the momentum, that is the product of mass and velocity. Secondly, it is important that momentum is equals to m into v, and positive momentum is towards right and negative momentum is towards left. It is not like that okay, every time right side momentum is positive and left side momentum is negative, but whatever is the situation, one side is taken as positive, the other side is taken as negative. That's it, what you have to consider, right? And it is vector, so we treat momentum just like vector. For example, when momentum of the bodies are in the same direction, we add them together, and the momentums of in the opposite direction, we subtract them. Yani mass is scalar, velocity is vector, so momentum entirely varies with velocity. So when velocity is towards positive, yani velocities towards right, or velocities of either two bodies are in the same direction, we consider that momentums would be added, and when they are in the opposite direction, they would be subtracted, right? And if the momentum is or the velocities are perpendicular to each other, then the momentum would be just um momentum will be just processed by Pythagoras theorem, right? What will we do? We will process the momentum according to Pythagoras theorem. So this is basically, these all are the evidences of its vector nature. So if I say that momentum mainly is a vector quantity, and that vector quantity is that which follows all the rules of vectors, so you have to take care of that. Okay, now come to the change in momentum. Change in momentum is either due to mass or velocity, but there are rare cases in which mass is being changed. I mean, in all of the cases, the velocity is changed, and velocity change. जायद अंकल को देखे होगे, ये टूट गया, ये रिपेयर कर रहे हैं, कल छुट्टी है उनकी, लाजमी ये पेन रिपेयर करवा दो। तुमने नहीं खोला आज? हाँ, उनसे रिक्वेस्ट करो, उन्हें बोलना वो लिखने के लिए पेन टूट गया अब्बू का, तो ये रिपेयर कर। Okay, so either change due to mass or velocity. So simply speaking, if you are going to find the change, there are two important things. There is lot of stuff written on this slide, but you have to focus only at this. The change in momentum is, if the bodies are moving in the same direction, it will be m into v minus m into u, where m is the same thing, the same body which is changing its momentum, but v is its initial speed, sorry, v is its final speed, and u is its initial. So it means that that body or that uh, object has different uh, situations of velocity, but mass is not changed. So whenever there is a single body, which formula will be used? Mv minus mu, but for the same direction. But in case of rebound, or when you are told that the body is rebounding, or yani both the bodies, a body, sorry, not both the bodies, a body hits and it reverses its direction, or a body hits the surface and it rebounds. So this word is important. The word of rebound is important. So when you are going to hunt this word in your description, that the body bounces back, body rebounds, or it moves in the opposite direction after collision, or it reverses its direction. So you people are advised to use this concept of bouncing back, and in this concept of bouncing back, you people the have to change the negative sign. Negative sign means the momentums would be added. Simply speaking, momentums will be added because of the negative sign, right? So what does it mean? That if mu is the momentum before collision and mv is the momentum after collision, then both would be added together, because I have taken negative sign outward. So simply speaking, here is the next thing what you have to take care of. You have to hunt the words. Please recall this, that bouncing back, rebound, or moving in opposite direction, then the change in momentum for the same direction is m into v plus u. But momentum change for opposite direction, yeah, bouncing back, is m into u plus v, or v plus u. You have to take care of this. Is it clear to all?
Yes, sir, clear.
Okay, now let's move towards another aspect or another area, and that area is basically law of this Newton's second law of motion. Newton's second law of motion is defined as the rate of change of momentum. We do not say that this is the law, or we do not say that this is F is equals to ma. Rather, we say that it is rate of change of momentum. What do we say? It is rate of change of momentum. So when we talk about this rate of change of momentum, it means that we are supposed to use this definition, right? But on the other side, it is same as that of F is equals to ma, because we can consider it. So statement for 2 marks is resultant force is equals to rate of change of momentum. Explanation is that you will write F is equal to delta P by T. Okay, you got it? Okay, so when we say that F is equals to m into v minus u divided by t, it is the rate of change of momentum in the same direction. But when you write m into v plus u divided by t, it is rate of change of momentum in opposite direction. So whatever the direction is, because I have addressed all that aspect before, So simply speaking, F is equals to m into v minus u divided by t, or v plus u divided by t. But it v minus u divided by t is acceleration, so that is the proof that F is equals to ma. That F is equals to ma. Is it clear? Is it clear?
Yes, sir. Yes.
Okay. Now we will move to uh, the next area, and that is that this is in some of the books it is written it is impulse. So impulse is change in momentum, it is not force. So impulse is change in momentum, so it is delta p by t. What do we do, or what do we write? It is delta p, which is delta p is equals to f into t, impulse. So that is why unit of the momentum is Newton second. What is unit of the momentum? It is Newton second. Is this clear?
Yes, sir.
Okay. Now this is nothing, it is just a numerical problem. That what do we do if a ball is moving here, and this is the kinematic question. If you have solved the kinematic theory, you people will see these type of questions. The ball is dropped from the height and it reaches to the ground with certain velocity. I have given you the velocity 4.2 meter per second, and it rebounds with a velocity of 2.5 meter per second. Calculate the force by which it hits the ground. So what I will do, I will simply say that the force is delta p by force is delta p by t, and that delta p is m into v plus u, because it is a rebound case. So mass is 2.5 kg, and what is your velocities? 2.5 and 4.2. So you will add them together, and then you will divide this with the time. And I have given you the time, that the time of contact for this is what is the time of contact? The time of contact is here I have given time of contact to you. Where is that? 12 milliseconds, right? Here is that it is in contact with the ground for 12 milliseconds. So for 12 milliseconds, whatever the force will be, you can simply calculate the force. That force is equals to m into 2.5 into 4.2 plus 2.5, right? Divided by 12. So that is all related to your uh, you know force exerted by your ball on the ground. Let me share the other screen with you, because it is making problem for me. Just a second. So here is the dynamic section, kinematics, dynamics. Yes, it will not have a glitch. Yeah, we were over here. Okay, so now let's talk about that. In this all chapter, we have to know about some of the laws of conservation. The laws of conservations are, once you will go through the laws, the first law is law of conservation of uh, momentum. Second law is the law of conservation of kinetic energy. I'm talking about kinetic energy. The third law is law of conservation of you know relative velocity. So there are three laws which are used to use here in uh, uh, in this dynamics chapter, and those laws are basically the laws here. First of all, law of conservation momentum. That law is asked to you for 2 marks. That for a closed system, the total momentum before Coulomb equals to total momentum after Coulomb. That is the law of conservation of momentum. What is that? That is the law of conservation of momentum. Is it clear to all? Yeah.
Yes, sir.
Okay. Uh, then there's an equation. Although this equation is basically using two masses, but I have to explain you why I have used two masses. The law of conservation of momentum, in a total closed system, momentum before collision equals to momentum after collision means that collision will take place. For collision, how many bodies are required? Right?
Two. Yes.
Two bodies minimum. So for two bodies collision, one is your let's say m1, and the second one is your m2. And when m1 and m2 are moving in such a way that m1 is having velocity u1 and m2 is having velocity u2, both are moving towards m1 is moving towards m2, so that will be approaching case. It means before collision is not has collision has not been taken place, and that is what will be the total momentum before collision? It is basically m1 u1 plus m2 u2. Okay, so this m1 u1 plus m2 u2 is the total momentum of the system before collision. Total momentum of the system before collision. Okay, is it clear?
Yes, sir.
Okay, so during collision, this is very important phase. Both the bodies are applying force to each other. What both the bodies are applying force to each other. So when both the bodies are applying force on each other, they are basically exerting opposite forces. Yani, that force is applied only in the time when bodies are colliding. It is not before and after. So during collision, this force is applied. So here I have just mentioned force on ball, force on blue is equals to force on red, and so on. So that is after collision. After collision, momentum is m1 v1 plus m2 v2. So you can say that according to law of conservation of momentum, m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. This is the master equation for law of conservation of momentum. Remember this thing. Law of conservation of momentum is just followed by this equation, and by this equation you can simply say that you can handle all type of issues. But the problem is sign convention. When you people are trying to apply the direction in the in momentum, so those bodies, as I earlier told you, that those bodies which are moving towards right, their momentum is taken as positive, and those which are moving towards left, their momentum will be taken as negative, no matter they are before collision or after collision. Okay, are you getting my point?
Yes, sir.
So if I say that both bodies are moving in opposite direction before collision, so m1 u1 will be taken as positive and m2 u2 will be taken as negative. So this is m1 u1 minus m2 u2. And after collision, now your m1 has reversed its direction, so it will take negative sign. So m1 v1 plus m2 v2. So according to the situation, you people are requested to apply the proper signs. Okay, so that means that you can manage your questions, or you can manage your cases accordingly. Above dekho, the second is law of conservation kinetic energy. Law of conservation kinetic energy, it is not law of conservation of energy. Remember this. That's why I have mentioned LCE, law of conservation of energy. It is not LCE, it is law of conservation of kinetic energy. That tells us the total kinetic energy before collision equals to total kinetic energy after collision. What does it mean? That kinetic energy of the system before collision is m1 u1 1 by 2 m1 u1 whole square plus 1 by 2 m2 u2 whole square. This is the kinetic energy before collision. And after collision, it is 1 by 2 m1 v1 whole square and 1 by 2 m2 v2 whole square. So both the energies would be equal to each other. This is actually law of conservation of kinetic energy. So that will be valid. Now moving on, if I say that there is another law, which is the law of relative velocity. This is a test actually. This is a test for your bodies to to have a to have a yani, whether the collision is elastic or inelastic. I will tell about that. That whether the collision is elastic or inelastic, that would be tested by one of this test, law of conservation of relative velocities. So when we are at law of conservation of relative velocities, that means that you are going to have the relative velocities of two bodies. Dekho, relative velocities, I have discussed that in kinematics, that approaching, in case of a relative approaching velocity in the same direction, you will subtract them, u1 minus u2. And in the case of relative velocities, when they are moving opposite in opposite to each other, you will add them. So this is really simple, that velocities would be added and velocities would be subtracted accordingly. This is the third law, right? In the case of separation, again, when the bodies are moving in opposite direction, sorry, in the same direction, relative separation velocities would be subtracted, and when the bodies are moving in opposite direction, the relative separation velocities are added together. Is this clear to all?
Yes, sir.
Now, this is the key, what I have mentioned, that for same direction, relative velocities are difference of both velocities. But for opposite direction, yani the motion in opposite direction, the both the sorry, relative velocity is sum of both the velocities. Now, if you say the law says that relative approaching velocity will be equal to relative separation velocity, right? That relative approaching velocity will be equal to relative separation velocity. Yani, how many laws did I tell you? Three. कौन से? Law of kinetic and law of conservation of momentum, law of conservation of kinetic energy, and law of conservation of relative velocities. Now we have three types of sorry, two types of collisions. One is elastic collision. The second one is inelastic collision. Okay. One is elastic collision, second one is inelastic collision, and the third one is a glancing collision. So I will talk about that glancing collision. But till this point, you people, how many collisions do you have? Two, elastic and inelastic. You people are asked about these collisions once, and secondly, you people are asked to test the collisions, whether the body has elastic collision or inelastic collision. So simply speaking, just moving onward, uh, elastic collisions are those collisions in which momentum, kinetic energy, and relative velocity all are conserved. Is this clear to everyone? Yani, all three laws are conserved. That is called your relative, sorry, that is called your elastic collision. Then in inelastic collision, only the momentum is conserved. Kinetic energy is lost. It means that is not conserved. Relative approaching velocity is usually less than the relative separation velocity. Okay. Relative separation velocity is usually less than relative approaching velocity. So that is why what you have to say, or what you have to do, that is that uh, they two both will be violated. Only one thing which is here very important for you, that momentum is conserved in both elastic and inelastic collisions. Momentum is conserved in both elastic and inelastic collisions. Is this very clear to everyone?
Yes, sir.
Okay. So let's talk about inelastic collisions and their details. All sticky collisions, which are actually in which the bodies move with the same final velocity, they are inelastic. What are they? They are your inelastic collisions. So all sticky collisions are inelastic collisions. What are they? They are inelastic collisions. So Mm, For example, if I have a body m1 and it has a velocity u1, then when that body will mm, collides with m2, m1 will collide with m2. If they stick together, then you people will have the final momentum m1 plus m2 into v, because now the bodies are same entities. Just did you see, both the bodies are now the same entities. That is why I can simply say that the law of conservation of momentum is now applicable in this way. You are going to apply law of conservation of momentum m1 u1 plus m2 u2. Law of conservation of momentum is applied in all the cases. So m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. That is what? That is the law of conservation of momentum. So just see, m1 u1 plus m2 u2 is equals to m1 plus m2 into v. So from here, I just have taken v common. So when v is common, you will get this formula that m1 u1 plus m2 u2 divided by m1 plus m2 into v. This is that formula which will help you out to find out the final velocity after collision in sticky collisions. Final velocity after collision in only in sticky collision. So I believe so that once you are you practice the questions, you people will have all these concepts uh, concreted, inshallah. Right? In sticky collision, the important thing is that kinetic energy before collision is always greater. So when kinetic energy before collision is greater, I can calculate it as kinetic energy 1. In step number 2, you have calculated the final velocity, right? Remember these steps. These are actually the key for success. Remember these all. Kinetic energy before collision is greater, so you have to calculate that. Kinetic energy after collision will be less, but you cannot calculate kinetic energy after collision directly. For that purpose, what you have to do, you have to calculate final velocity after collision. So final velocity is basically m1 u1 plus m2 u2 divided by m1 plus m2. After that, you will get final kinetic energy, and at fourth step, you will calculate the loss in kinetic energy. So please remember all these steps for your sticky collision. This is a question I have just figured out an MCQ here in front of you, right? Yani two trucks which are moving in opposite direction with the masses of 5,000, 5,000. The speed of truck of coming from left, a truck A is 20 meter per second, and then the opposite moving truck has speed of 30 meter per second. Calculate loss in kinetic energy. This is an MCQ, simple MCQ. But for that MCQ, you have to work a lot. For example, you have to find out the kinetic energy before collision. I have calculated that kinetic energy before collision. Then that comes up at 3250000. Then you have calculated final speed of both the trucks when they stick together in by this way: m1 u1 plus m2 u2, sorry, m1 u1 minus m2 u2, because direction is opposite, in they are moving in opposite direction. And then m2 v2, yes, m1 v1 plus m1 u1 minus m2 u2 divided by m1 plus m2. And then finally, what will you do? Finally, you will just plug in all the values of final kinetic energy. Speed is that 5. Minus 5 means now the trucks, both the trucks will move towards left after collision. It does not matter. The task is loss. So you will subtract kinetic energy 2 from kinetic energy 1, and then you will find that the loss is 3125000. So these type of questions are asked to you in next class. Inshallah, I will try my best to complete this glancing collision and all that data, and your chapter would be again completed, another chapter. So I request you all, please pace up your work and don't let me to move far away from your practice. Right? We should have a, parallel path. Okay?
Yes, sir.
Any question? No question at
No,
all?
sir.
Okay.
Yeah.
See you then, inshallah.
Traffic, sir.
Allah Hafiz.